This is Richard Anthony Marca,
And Aidan Mendoza.
and this is an overview in machine programming. A general background of machine programming. Machine programming is about automating the development and the maintenance of software, like creating software that creates its own software. One current theory about machine programming is the concept of machine learning, or using artificial intelligence to learn by gathering data. In addition to using machine learning techniques, which are approximate types of solutions, machine programming also uses other methods. One such method is creating formal program synthesis techniques that provide mathematical guarantees to ensure precise software behavior. The history of machine programming. One of the first examples of programming in general is what is known as a clockwork device. Many clockwork devices were so intricate that they could be, in a sense, programmed to complete a series of complex tasks, such as dancing or writing. The earliest known example is the Antikythera mechanism from 200 BC to around 70 BC. In 1804, the Jacquard loom punch card system was one of the first examples of a binary system. The system made it possible to automate the process of weaving different patterns into material. In 1883, the first programming language was developed when Ada Lovelace and Charles Babbage worked together on the analytical engine, which was a primitive mechanical computer. In 1952, a computer scientist by the name of Arthur Samuel developed a program to play checkers, which is the first to ever learn the game independently. In 1959, John McCarthy created LISP, which is a programming language that was designed for use in artificial intelligence research. And today, it can be used with both Python and Ruby. In 1972, Dennis Ritchie developed C, generally regarded as the first high-level programming language. In 2006, companies such as Twitter, Facebook, and Netflix started utilizing AI as a part of their advertising and user experience, or UX, algorithms. And in 2020, OpenAI started beta testing GPT-3, a model that uses deep learning to create code, poetry, and other such language and writing tasks. Today, machine programming is used in self-driving cars, AI machine learning models, and the creation of new hardware.
This slide is on the applications of machine programming. Automated software development focuses on streamlining the coding process. This includes code generation, which automatically creates codes from templates, and optimization techniques that enhance existing code performances. Refactoring tools are used to improve code structures without altering the functionality, while continuous integration and deployment automate the integration and the release processes, which speed up the development cycle. In a data analysis context, automation enables the processes to be significantly increased in their efficiency. Certain data tools correct inconsistencies in data sets, and predictive analytics can forecast trends based on historical data. Other visualization tools can generate insights from complex data, and real-time processing done with the machine programming processes allow for very quick analysis of information. In a context of AI and machine learning, it's transforming applications in many different areas of work with advancements such as natural language processing services, which enable machines to understand and generate human language. Also, self-optimization systems can learn from user behavior and improve performance. On the other hand, computer vision technologies, as mentioned in the data analytics section, can analyze visual data and create charts and such from that. In robotics, they can benefit from machine learning by incorporating autonomous navigation softwares, which would enable robots to operate without human intervention. Also task automation can enhance efficiency of processes such as construction or development of new items. Lastly, in a game development context, automation, it can reshape how games are created and played. Machine learning is a big part of processes such as procedural generation, which can create unique game environments. And as seen in newer games nowadays, they can be used for adaptive non-player characters or NPCs to respond to the player and provide a dynamic experience. OpenAI is a leading organization in the development of cutting-edge AI tools. They've made machine programming accessible through programs such as GPT, and this enables developers and average people to leverage natural language processing capabilities in their applications. DeepMind is another company, and they're renowned for their breakthroughs in reinforcement learning and other areas of machine programming. Particularly, they are known for implementing machine programming tools in a healthcare environment. Stanford University is a prominent institution, and they offer leading research programs in AI and machine learning, which are derivative of machine programming. This university is very well known for its influential publications in the area, and they contribute greatly to the advancement of knowledge and technology. Companies such as Google and Microsoft are pioneers in AI and machine programming. They've developed powerful tools such as TensorFlow and Azure Machine Learning, which provide developers with robust frameworks for developing and deploying AI applications.
The paper I chose to look into for machine programming is a systemic literature review of the impact of AI models on the security of code generation. One of the main questions they asked in this paper was how serious and widespread are the security flaws in code generated using AI models. Through a systemic literature review, this work reviews how AI models impact software security by reviewing what security flaws of well-known vulnerabilities are commonly hidden in AI-generated code, and by providing a comprehensive and systemic overview of the impact AI has in secure coding, it discusses how vulnerabilities in AI-generated code can be exploited to compromise security. They also list ways to improve the security of AI-generated code by using common standards. This research showed that AI models do not produce safe code and have inherent vulnerabilities despite mitigations that have been used today. But even though AI is not necessarily secure, does it perform better than humans doing the same tasks? This paper also discovered that when generated with AI support, different programming languages have different security performances. AI-generated Python code seemed to be more secure than AI-generated code of the C family. When comparing the security of AI-generated C or Python, the literature converges on reporting that security of the former is worse. Looking at security exploits enabled by AI-generated code with security weaknesses, 3 different attacks are most frequently reported: SVEN, code attack, and codex leaks. Such attacks are reported to be used to decrease code security, creating adversarial code and personal data leaks over automated generated code. Some of the ways to improve their effectiveness and efficiency of security is by creating modifications to the data set, raising awareness of the context of prompts and how to increase their quality to affect security of the code generated positively, and using common security processes, policies, and a degree of mistrust of the AI-generated code. AI generated code should pass specific processes, such as security verification before being accepted, and educating end users on AI models and their limits. Therefore, AI models for secure code generation needs to be approached with due care.
The paper I chose to write my slide on is the 3 pillars of machine programming. In this paper, the authors, they share their ideas for improving machine programming by focusing on 3 key areas: intention, invention, and adaptation. Intention is about helping computers understand what users want more easily. Intervention means using machine learning to create and improve computer programs automatically. Adaptation focuses on making software that can change and fix itself without needing too much human help. Together, these ideas aim to make programming easier and more efficient. The authors suggest 3 main ways to make programming better and more efficient. 1, understanding user intent. They plan to create tools that allow people to express their needs simply, like understanding everyday language or gestures, so they don't need to be experts in coding. 2, automating code creation. They talk about using machine learning and machine programming to let computers write code on their own based on what users want, which would greatly speed up the process and help reduce mistakes in coding. And 3, self-adapting software. They talk about developing software that can fix problems and improve itself automatically, which would overall mean less work for the people whose job is to maintain it. These solutions, they aim to make programming more accessible and more efficient, especially in terms of cost. By using these ideas, the authors expect several positive outcomes. Firstly, they expect better tools for users. They propose systems that can help capture what users want simply and make programming less complicated, as stated earlier. Machines that write code, that computers would be able to generate code automatically, saving time for developers. And then, as mentioned before, the software that fixes itself. The research sets the stage for transformative applications in machine programming, enhancing usability and expanding access to software with development tools. This framework could lead to significant advancement in how both developers and non-programmers interact with technology, which would greatly foster innovation across various fields of work and study. Impact on software development. By automating simple tasks such as reading files, parsing data, and software development testing, the rate of software development can be greatly accelerated. This automation reduces the time developers spend on routine activities, allowing them to focus on more complex aspects of their projects. Advances in machine programming will also enable exponential optimization of code across hardware platforms, which would lead to enhanced performance. As algorithms improve, software will be able to run more efficiently and effectively, which would leverage the full capabilities of the hardware that's being used. Improved adaptation techniques will allow software to self-update and resolve issues autonomously. This capability will reduce the need for manual maintenance, which would make software systems more resilient and cheaper to run. Lastly, enhanced AI-human interaction is likely to change the way software developers work, and over time, they're going to have to get more used to using it. This intertwining of human and AI development will allow developers to designate routine responsibilities to AI, and this will increase productivity and innovation in software development. Ongoing research into quantum computing may lead to practical applications that can solve problems beyond the capabilities of traditional computing methods. Ongoing research into quantum computing may lead to practical applications that can solve problems beyond the capabilities of traditional computing methods. The integration of machine programming with AI and hardware design has the potential to enable faster development cycles and optimize performance tailored to that specific application. Additionally, there's likely to be an increased focus on energy efficiency in computing. Prioritizing energy-efficient designs would lower operational costs, extend the lifespan of hardware, especially as systems become more advanced and potentially strained by demanding processes.
Machine programming has an impact on cybersecurity as well. AI-generated code has impacted the software security engineering community by highlighting the importance of setting up security measures and processes customized for AI-aided code production. Raising awareness of the context of prompts and how to increase their quality seem to affect the security quality of the code generated positively. Security processes, policies, and a degree of mistrust of AI-generated code can help with security, and it should pass specific processes such as tests and security verification before being accepted. And educating end users on AI models and for code generation on their limits. That is the end of our presentation. Thank you for listening.